Hey everybody, Greg here. So what you're looking at is a beaker of swirling water and we've just dropped in some blue food coloring. Alright, what's going to happen? Well, we did this in class, so I think you know what's going to happen. And also it's similar to when you put cream in coffee and other things you've seen. So let's just fast forward to a quicker version because I think you know what's going to happen. Alright, we're just going to get some blue liquid, right? The food coloring is just going to spread out through all the water and we just get some blue liquid. Alright, so while we know what's going to happen, there's still an interesting question that Professor Waits asked in class. And that question is, why does it do this? Why isn't it that the blue liquid just stays in the middle? Or why doesn't the blue liquid just go down to the bottom here and stay there? Or go to the edges and not hang out in the middle? Or maybe it could go and just the whole thing could be blue and then you wait a little while and it all comes back to the center. Why does it just stay as a homogeneous blue liquid? This food coloring just spreads out through the entire thing equally. And I want to answer that question for you by giving you a little puzzle. So here's the puzzle. The puzzle is I have a box here, and this box has 7 separations. That is, there are 8 boxes here. And what I'm going to do is I'm going to ask you to look away, and in these boxes I'm going to put either an X or an O. And I have 6 X's and 2 blue O's, and I want you to think about the different possibilities of what it'll look like. So okay, just humor me and look away for a moment starting now so I can do this. Alright, and you can look back now. So, here's a placement that you could have had, that I could have chosen. I just did this randomly. And the question I want you to think about is, which is more likely? Is it more likely that I would have chosen something with the O's right next to each other? Or is it more likely that we'll have the O's separated by some X's? There could be 3 X's, 1 X, any number of X's in between there too here. But which is more likely, that they're next to each other or there's some X's in between them? And I think that you probably have a good guess for that. So let me ask you a harder question. How much more likely is the situation that you think is more likely? Now, if you'd like a nice sense of satisfaction, then please pause this video and figure this out on your own, and then you can play it and see if you were right. And if you don't want to do that, then you can just keep watching and we can do this together. All right, so how would I figure out which is more likely? Well, I would just, I just count it. Just count the different placements we could have. So first, how many different placements are there? Well, here's one placement. There's the O's in the 2 leftmost spots, and then I'm not going to write the X's, but the X's would be in the 6 to the right, these 6 spots. Okay, then another placement we could have is we could have this placement, or I guess we could think about all the placements where we have one of the O's, we leave the first O here in this first box. So it looks like there will be 7 of those where we leave that O in the first box. So there are 7 placements like that. Now let's move the first O to here and see how many placements we have like that. Okay, so now we move the second one. Well, we can't really move it to the first one. That looks just like the first placement we had. So so we have this one. That one looks new. Or we could move it here. That one looks new. Or we could take it and move it. Okay, so it looks like the same thing except for we just had to leave out the first box. So this is going to be 6 new placements. And then now we can move this move the O to the next box and do the same thing. So move it over here. Somehow I accidentally gave that thing an eyebrow. Sorry about that. Alright, so when we keep doing this, what's going to happen? Well, we'll just get, in this next one, we'll get 5, and then we'll get +4, and then +3, +2, +1. And the number of placements we're going to get is 28. If you have any questions, feel free to email me. But we'll have 28, because this pattern will continue. And so how many of those placements were the O's next to each other? Well, now it's just, you can just think about how many different placements we had to start out with. That is, how many times did we move this first O? Because when we started out, we put the first O and then we put the second one right next to it. And so we had this one, and then we also had the situation where, sorry about that, where we take the two O's, we can just move them together because we're going to try to keep them together. So we could have them here, we could have them here, we can move them throughout all of these, and the only difference is they're separated by different lines in each of those situations. And so there are 7 lines, so there's 7 different situations where the O's were next to each other. So that means the leftover ones are when they weren't. So this is next to each other, and then when the O's are not next to each other, there are going to be 28 minus 7. There's going to be 21 of that type. So it's more likely that we're going to have the situation like this, the situation where it's separated. And so that's it's less organized. And so why am I talking about this? Well, okay, let's think about what if instead we had 10 boxes. That is, we had 8 of the red X's and 2 of the blue O's. Well, if we do the same thing, that we find that, so in the first case we had 3, it looked like there were about 3 times as many disorganized. So there's 21 is 3 times 7, so there's 3 times as many situations where the O's are separated than next to each other. And here it's going to be 5 times more likely that we'll have, you know, something where we have some X's and then the O's separated. So the bigger the system is, it's even more likely that you won't have the O's next to each other. So we can think of a system where we have a beaker, and so in the beaker there's this water, and we can think about all the different little places in the beaker, you know, separated in boxes like we did the boxes above, and then we drop in the blue dye, all these blue O's, and you can think of the water molecules as the X's. So you have all these X's, and then when they bounce around, it randomizes and chooses one of these situations randomly, and you can figure out when you look away after you drop the dye in which situation is more likely. It's more likely, just like before, that we'll have the O's separated by X's. The blue dye will be separated from the other blue dye, and that's more likely, and that's exactly why you'll have the blue dye go and spread throughout the entire beaker, become homogeneous. It's just because there are more situations that look like that than the blue dye being arranged right next to each other. So I hope you guys enjoyed this. If you have any questions, feel free to email me, and have a nice day.